There are 4 very difficult to weld materials. So let us discuss one by one. First is aluminium. Aluminium is very difficult to weld material because as soon as the aluminium is exposed, it forms a thin layer of aluminium oxide over it. Now base is aluminium. The problem is this aluminium oxide is a ceramic. So the moment you want to use any heat source, because ceramics are known to have very high melting point, so the moment you want to penetrate the ceramic layer, the temperature is already quite high. So because aluminium melting point is very low, because there will be a thin layer of aluminium oxide which is a ceramic, it is very difficult to weld aluminium. So only way we can weld aluminium is this. When you are connecting to a power source, the aluminium should be given negative polarity and electrode should be given positive polarity. So when the electrons are coming out from the work, the aluminium is the work. So when the electrons are coming out of the work, the ceramic layer will peel off. And that will make a contact between the arc and the aluminium, fresh aluminium. So that's how the welding is possible. This phenomena due to which aluminium oxide is peeling off is called cathodic cleaning. And without cathodic cleaning, it is not possible to weld aluminium. Now there are some tricks in which AC also we are using, alternate current also we are using to weld aluminium. But in AC, 50% of the time workpiece will be negative and 50% of the time it will be positive. So in case of AC, there will be partial cathodic cleaning. So technically you can weld, but best quality weld will be achieved when in case of DC, when the workpiece is given negative polarity. So that was the first material very difficult to weld, and I will tell you the tricks how each and every element can be welded. Now second one is copper. The copper is having very high thermal conductivity. Okay, na? Copper is having very high thermal conductivity. So suppose you would like to spot weld. Or you can say projection weld. So during the stage of projection collapse, or when the heat is developed, most of the heat will be transferred to the work. Most of the heat will be dissipated from the welding area. So you will not be able to melt and weld copper. Even if by adjusting the current and time, even if you are able to weld, there will be large amount of heat affected zone because the heat is getting dissipated heavily from the welding area. So because of high conductivity, coppers are very difficult to weld materials. Next in line is the cast iron. Cast irons are very difficult to weld because, let us say, grey cast iron, there is a graphite. So when you try to weld, the graphite will come out, or most probably there will be cracks during welding. So as per one of the book written by my teacher, so what he says that only way you can try to weld cast iron is by gas welding using carburizing flame. So by using carburizing flame only, it is possible to weld cast iron properly, otherwise it is almost impossible to weld cast iron. Now the next most difficult weld material is stainless steel. As we know very well that in stainless steel, at the grain boundary, there is a chromium oxide. At the grain boundary, there is a chromium oxide, and this chromium oxide provides a corrosion resistance. So when you are welding material, when you are welding this stainless steel, so everybody knows there is a bead. Everybody knows that there is a bead, and here there is a heat affected zone. There is a heat affected zone. So when you try to weld stainless steel in the heat affected zone, what exactly happens? That this chromium combines with the carbon already present in the material or maybe in the atmosphere, and at the surface there will be a thin layer of chromium carbide, just like a dust, and after the welding, dust goes away. So after welding operation, it appears that you have performed the welding operation perfectly. It appears, but you know what is the problem? In the heat affected zone, there is no chromium oxide at the grain boundaries. So after some time period, the heat affected zone portion of the material start corroding, and this phenomena is called weld decay. In stainless steel, there is a phenomena called weld decay. So how we can weld such materials, stainless steel? My arc should have a concentrated source of energy. For example, plasma arc welding, then electron beam welding. By these processes, I can weld stainless steel, because there is a thumb rule in welding that more concentrated source of energy it is, faster will be the welding speed. More concentrated source of energy it is, faster is the welding speed, and the energy source will have less time to interact with the surroundings, so heat affected zone will be less. So heat affected zone is less, the weld decay phenomena will be almost nil. So a stainless steel can be welded by either plasma or by electron beam. So these are the four most difficult to weld materials. There are others, but for competitive examination, these four. Tuned in for other technical discussions.